Introduction. We will look for history Cramer's rule. Gabriel Cramer, a famous mathematician, created and developed Cramer's rule in 1750. He developed Cramer's technique to determine the solution to a system of equations with n variables and the same number of equations. Next, we look for Cramer's rule. What is Cramer's rule? Cramer's rule is a realistic and efficient method for solving systems with an arbitrary number of unknowns, as long as the number of equations is equal to the number of unknowns. If a unique solution to a system of equations exists, Cramer's rule will reveal it. When the coefficient determinant is not zero, Cramer's rule applies. The values of the system variables are computed using determinants of matrices in this method. As a result, Cramer's rule, also known as determinant technique. Next, Cramer's rule is a formula for solving a system of linear equations with many equations as unknowns that is efficient whenever the system of equations has a unique solution in linear algebra. When the determinant of the matrix in AX equal to B is equal to 0, Cramer's rule fails to produce the values. Cramer's rule will yield a solution in terms of the coefficient matrix determinants and matrices derived by substituting one column with the column vector of the right hand side and of the equations. Next, AX equal to B is a system of linear equations written in the matrix form, where A is a coefficient matrix that must be a square matrix. Then X is a column matrix with variables, and B is a column matrix with constant on the right side of the equation.
Purpose of study, problem statement in this application. Zep Furniture Store Sdn Bhd is a large furniture factory in Malaysia. The factory sells various types of home furniture such as chairs, tables, sofas, kitchen cabinets, cupboards, television cabinet, and so on. After 5 years of the factory operating successful, the owner of the factory held a massive sale and the price collapsed for each furniture sold. Maria, Siti and Nurin chose to spend time going for a big sale at Zep Furniture Store Sdn Bhd to buy some home furniture because the price offered is very cheap. Maria spent Rm 1,868 to buy 6 chairs, 3 tables and 1 cupboard. Siti spent Rm 2,286 for 2 chairs, 2 tables and 3 cupboards. Nurin pays Rm 1,800 for 5 chairs, 1 table and 2 cupboards. Find the price for each piece of chair, table and cupboard sold by the factory. Objective in this application, point 1 is to apply concept contained in this subject, which is elementary linear algebra, and to form augmented matrix that represent the system of linear equation. Next, point 2 is to determine the best strategy to solve these problems by using matrices, and we have chosen to use Cramer's rule to solve this problem. Lastly, point 3 is to calculate the price of each furniture sold by Zep Furniture Store Sdn Bhd, chairs, tables and cupboards.
Methodology. For our problem, we use method of Cramer's rule. So theorem Cramer's rule, this is coefficient matrix of A. So this is column for E. Then the unique solution of the system is given by xi equals to determinant of ai divided by determinant of A, where I equals to 1, 2, 3 and so on based on the equation. And determinant of ai is a matrix obtained by replacing the I column with column matrix B. So, the steps in Cramer's rule. First, we need to identify coefficient matrix A, the variable matrix X, and the constant matrix B. Next, we find the determinant of AI and determinant of A. To find AI, we substitute matrix B is matrix B into column 1 of matrix A. We put the matrix B into column 1 in matrix A to find A1. And then we use the same step to form A2, A3 and so on. So, lastly, we find X1. To find X1, we use this solution. X1 equals to determinant of A1 divided by determinant of A. So, it's same to find X2, A3, X3 and so on. So Cramer's rule is only applicable for linear system with non-singular coefficient matrix. If determinant of A equals to 0, then the linear system does not have a unique solution. For homogeneous linear system with unique solution, determinant AI equals to 0 for all values I, hence xi equals to 0 for all values of I. There is trivial solution.
For solution, first we need to identify the variable. So first we need to substitute the furniture into variable, such as for chair we put it as x and table as y and cupboard as z. For the solution we use the Cramer's rules method. Okay, first we need to identify the coefficient variables and constant, which is a, x and b, just like written in the slide, which is the coefficient a is 631, 223 and 512. Okay, for the second step we will need to find the determinant of a. To find the determinant of a, we will need to use the cofactor expansion method. Hence, by using it step by step, we will get the determinant of a is 31. And for the third step, we need to find determinant of a1. As you can see in the slide, there already has the coefficient of a1. This is the coefficient of a1 which got by substitute the matrix B into the first column of matrix A. Okay, then to find the determinant of a1, we will use the cofactor expansion just like to find the determinant of A. Then we will get the answer. Determinant of A1 is 3038. Next, for the fourth step, we need to find the determinant of A2. It's almost the same with to find determinant of A1. Just the difference is to find the coefficient of A2, we will substitute the matrix B into the second column of matrix A. Then we will get as shown in the slide with of coefficient A2. Then by using the same method of determinant to find the determinant of A2, which is using the cofactor expansion, then we will get the determinant of A2 is 7750. For the fifth step, we need to find the determinant of A3. It is same as to find the determinant of A1 and A2. So based on the slide that has the coefficient of A3, the same as to find the coefficient of A1 and A2, but change for the column we put the matrix B. Then to find the determinant of A3 using the cofactor expansion also, hence the step are same, and then the answer for determinant A3 is 16,430. As of the result, to find the values of x, y and z, we will need to divide between the determinant of new coefficient with determinant A. Hence, to find the values of chair, which the variable is x, we will need to divide the determinant A1 and determinant A to get the answer 98. For the table, which the variable is y, we need to divide the determinant A2 with determinant A to get the answer 250. Then for the cupboard, which the variable is z, we need to divide between the determinant A3 and determinant A to get the answer 530.
Discussion. To solve the problem, first we turn problems into mathematical sentences. The indicator for the items are x is chair, y is table and z is cupboard. Next, we convert the statement to a system of linear equation. After that, we apply Cramer's rule to get the value x, y and z. First and foremost, we identify the coefficient of matrix A, the variables of x and the constant matrix of B. Then, we find the determinant of A, A1, A2 and A3. At the end, we find the value of x, y and z and we get x equals to 98, y equals to 250 and z equals to 530. Hence, we can know that the price of a piece of furniture by ZEFH Furniture Store Sdn Bhd, which is chair, is Rm98, table is Rm250 and cupboard is Rm530.
Conclusion. We may deduce from the problem description that applying Cramer's rules to solve a system of equations is much faster and more efficient than other methods. It also requires some additional rule and matrices understanding, but the benefits greatly exceed the difficulty of understanding some basic row operations rules. As we can see from the result and the debate that we've had, Cramer's rules has shown to be the most straightforward techniques for achieving the desired result. Cramer's rules is a practical and efficient method for solving system with an arbitrary number of unknowns, as long as the number of equations equals the number of unknowns. Cramer's rules will give us the unique solution to a system of equations, if it exists. Cramer's rules is also one of the most convenient ways to solve a system of equations. That's all from us. Thank you.